Okay, so although there's no video of me actually building this, this is a solar powered LM386 portable speaker. I'll just show you it working. Got it connected to an MP3 player and it is being powered by the sun. And just to prove it's being powered by the sun, there we go. Now that's fine for sunny days. However, in the UK we don't really get very many of them. It's exceptionally hot and sticky today, but that's the exception from the norm. So what I'm going to do is I'm going to use some old mobile phone batteries and we're going to connect them in series to give me 12 volts, and which is exactly the same as the solar panel will give me. And we're going to put the batteries inside the speaker enclosure. So I'll rip this thing apart now. We'll have a look inside. You can see the circuit that I made with the LM386. You can see how I constructed it. I mean, literally, it's just solar panels hot glued on top of a speaker with some holes drilled in it for the wires. And obviously, there's 3 solar panels on the top. Well, there's actually 4. This little one here is going to be for an MP3 player. And that runs on 1.5 volts, you see, so, and that is exactly what that solar panel gives. It gives 1.5 volts at 95 milliamps. So that's what I'm going to do. I'm going to connect an MP3 player to that solar panel. So then I'm going to have a portable MP3 solar powered amplifier or battery. And what we're going to do, we're going to connect it so that we can flick a switch and power either from the battery pack or from the solar. I'm not going to put a charge circuit in there because of the way the batteries are wired up. I'm not removing the charge protection circuits from the batteries. So it'll be a case of when the batteries are flat, I'll have to take the batteries out and charge them individually because I haven't got a charge balancing board at the moment. But my plan is to get one and use it to charge the batteries. So I've chopped a small piece of Vero board, and what we're going to do with this is we're going to use this Vero board. We're going to connect the battery pack up to it. We're going to connect the solar panel up to it, the switch, and we're going to stick a couple of diodes on there. I think these are 1N4007s. They're not the ones that I would have chosen to use, but they are the only ones that I've got that I can use. I've got some others here. I think I've got 1N4048, but they're ultra fast switching diodes, and I don't really need them for this project. They'll be best suited in a different circuit. So I think what I shall do, I'll put a capacitor or a couple of capacitors on this Vero board, just so that when the sun goes behind a cloud or a cloud goes in front of the sun, the fade out of the amplifier is not quite so instant, and there's going to be a little bit of power stored there. Now I have actually got a solar powered battery bank. The battery in it failed, so there's the circuit board out of it. Now you might be asking yourself, why aren't I going to use this? Well, because this only deals with one lithium polymer cell. It's actually fairly clever. Uses a coil there to boost the voltage, So it's a DC to DC boost circuit really. There's a couple of op amps on there. I think they are LM358s. However, there's one LM358 there, one LM358 there. There must be one for each solar panel. In fact, I've followed the traces and they do actually connect back to the solar panels. So, but that would be perfect for what we're doing if only it would charge 3 cells. But it doesn't. So that idea goes out the window. Okay, so to make plugging and unplugging the battery pack easier, we're going to use this little connector here. I think that, to be honest, that probably came off a computer motherboard. So we will connect that to the circuit board and solder it on. If I should put it the other way around, probably make it a bit easier for me to disconnect the battery pack. Yeah, perfect. So I shall solder that onto there, like so. I suppose it helps if I'm doing it the right way up, doesn't it? Okay. So that will make connecting and disconnecting the battery a lot easier. Hell of a lot easier, to be honest. Okay, so I'm now going to put one of these diodes on. This is really just, like I say, to stop the battery power, if anything ever goes wrong, the battery power going towards the solar panels. Or from the solar panel back to the batteries. Which is why I've decided to use 2 diodes. So we've got protection in both halves of the circuit there. The only problem with using salvage components. May well be cheap, but you do end up fiddling about quite a lot trying to get things to fit. But it is worth it. There we go. There's that diode now on the Vero board. So we shall solder that into place now. And then we just need to break the track on the Vero board there so that the diode actually does what it's supposed to do and cannot be bypassed. Now you can actually buy a special tool for doing this, but really all it is a kind of scalpel anyway, and is rather expensive. So I decided to stick with what I've already got, which is a screwdriver or a Stanley knife. Because all you have to do is scrape the copper off the back of the board, and all that does is break the continuity from this half to this half. Now we'll get the continuity tester out and we'll just double check that there is not continuity between here and here. So provided we do not hear a beep, which we do not, and then we'll try it this way, positive this side, and the diode is definitely working, because when I measure it this way, we're measuring resistance of about 595 ohms, and the other way there's just no resistance measured at all, because there's no current flowing from this side to the board to that side. So the diode is working and it's doing its job. So now we've got that connector on the Vero board, you can see exactly how I'm going to connect it up. I'm going to connect the battery pack just like that. That is actually a power connector from a floppy disk drive. Obviously I'm just going to use the red and the black wire, so I can get rid of the yellow and the black there. They aren't actually connected up. So there we go. That will be the power connected from the battery pack. I'm going to do more or less the same thing for the solar panel. I'm going to use this connector, provided it fits through the Vero board, which it does, it fits fine, yes. So we shall solder that one into place now. And yes, I've found another one, exactly the same type of connector, except this one's got a yellow and a black wire, so I will be able to differentiate between the positive and the negative input for the solar panel. So I shall get that connector soldered onto the board now. It's for exactly reasons like this that I actually take all these little connectors out of broken electronic devices, because you never know when these things are going to come in handy. There we go. So that's both our connectors now connected up. We'll get the other diode on there now. You must remember when you put in a diode in that the white line on the diode, I don't know if you can see it there, but there is a line on that diode at one end, on the right hand side it is, shows the flow of current. So you know that power will flow out of the end where the white line is. We'll get that soldered in now. And again, I'll just get the Stanley knife and break the track on the Vero board there, like so. And if you can see that just there. Okay, so now that we've got the diodes on there, what we're going to do is we're going to connect up the switch for selecting whether we want power from the solar panel or power from the solar panel or power from the battery. Now, as I said, this switch is two positions. This position, power will flow from there and out of the middle, and in this position it will flow from there and out of the middle. It's perfect for the purpose that we need, because it basically switches power from one source to another, that switch. I've tested that with the multimeter and the continuity tester, so what we need to do now is we need to connect up some wires so that we can connect each side of the power circuit to that switch. So I have pre-tinned these wires, and I'm going to use a red wire for the battery pack and a yellow wire for the positive of the solar panel. And the only reason I'm doing that is because the power coming in from the battery pack, positive is red, and the power coming in from the solar panel is yellow. That is my only thinking behind that. So we shall get those soldered on now. And now for the other half. So these two wires will go to that switch, and then from the center point of this center connection of that switch, we will connect to the power of the amplifier. So I know this looks a bit, it looks a little bit dodgy, but it's going to work perfectly for what I need. So and there we go. So switch, that position will be solar power and that position will be battery power. Now we just need to connect our wire up to the center terminal of the switch. So I'll put the switch back into the massive crocodile clip thing. And we will attempt to solder this wire on now. There we go. There we have our 3 connections. And I think on the center one I will put a piece of heat shrink. Just so that none of these can short out, that's all. Now the soldering iron is not doing a very good job of shrinking the heat shrink, so I shall grab my lighter. Okay, so I know this little red wire here looks a little bit singed, but it'll be fine. I just use my lighter to shrink the heat shrink, and now I know there's not really any possibility of any of that shorting out. And we're just going to grab the continuity tester, and we're going to double check that the switch actually works properly. So we will connect the center position up to the negative probe, and there we go. So that would be indicating power in from the solar panel. We'll flip the switch the other way, and this will be indicating power in from the battery. There we go. No continuity there, so there we go. I know that switch is wired up correctly and working. Okay, so I've had a raid through the parts drawer and I found 2 capacitors. They are 1000 microfarad at 25 volts. And I'm just going to put them onto the Vero board. Obviously, positive leg goes to the positive connection in from the either battery or solar panel. And the negative is going to go to the negative. And obviously we've got 2 power inputs, so I've got 1 capacitor for each input. We'll get those soldered on now. So there's 1 capacitor, and now we'll do the same for the other side. And there we go, there's the two capacitors. Okay, so this is going to be our power connector for our battery pack. And we now need to wire these batteries up in series. So literally all I'm going to do is I'm going to tape the batteries together like that. We connect the positive and negative terminals of the battery. But I obviously need to shorten these wires somewhat. We don't want 6 million miles of wire floating around inside the speaker enclosure. Okay, so this one I'm not going to touch the lithium polymer, so I'm not going to change the length of the wires on that. I'm just going to do these mobile phone batteries. There is a reason for that. That's because the wires onto this charge protection circuit, ever so tiny, ever so fiddly, and I really do not want to be pulling the wires off there when I strip them. So that would almost work perfectly, almost, because that's positive, that's negative, so yes. That is how we'll do it. I will connect that wire to there, and then we will connect that wire like that, the purple and the black wire together with a bit of heat shrink. Okay. This is where I find myself wishing that I didn't let the kids come in and use all my tools. I know what my dad used to whinge about now. And all I was doing was fixing my bike when I was a kid. For some reason I had this fixation with 10mm spanners. Every single 10mm spanner my dad had, I used to lose. I could never understand where they went. Okay, so I need to be somewhat careful here not to pull the connections off the batteries, because I really do not want to have to remove the charge protection circuits. I know for the time being that means whenever the battery's flat, pulling it out and messing about, disconnecting all of them and what have you, but to be honest, I'd rather do that. And that it doesn't matter how long I leave the batteries on charge for, they aren't going to explode. I mean, you just have to look at this one, where we removed the charge protection circuit and it was left on charge for literally 25 minutes too long. You know, it is rather bowed out. I don't know whether you can see that very well there, but we'll try stabbing that with a knife later and we'll see what happens. Okay, so we want to wire these in series, so we want to go from positive to negative and then positive to negative, so we end up with all three batteries joined. So let's double check the polarity. We will go positive to negative, like so. And then we will go positive to negative again. Okay, so that leaves us with the yellow as our positive and the black there as our negative. Let's see if we can find a better way of stacking these. Something along those lines there will be fine. So we will solder those two connections together and then put some heat shrink on them. And then we're going to concentrate on making the battery pack so that the three batteries will stick together. We'll double check the voltage of the pack. It's very important when you're messing about with lithium polymer batteries or lithium ion batteries that you make sure that the polarity is correct. These things can be ever so dangerous. So just a word of caution. We will now check the voltage of this battery pack. And we've got 12.29 volts. I don't know if you can see that, but there we go. So we've got our 12 volts. Okay. Now let's make this just a little bit safer. So we will trim these connections down a little. And then apply some heat shrink. There we go. That's heat shrink applied to there. And there's my other piece of heat shrink, which we shall apply to here. And there we go. We're just going to gaffer tape these cells together. I'm not going to use too much gaffer tape. The glue on it is ever so strong, and when I pull it off to separate the 3 cells to charge them, I do not want it pulling the silver coating off the lithium polymer cell. So there we go, there's our battery pack. Okay, now to connect up our battery connector. So black to black and red to yellow. There's one connection, and we will insulate that now. Now my aim here is not to use too much gaffer tape because it is a pain in the arse to get off, and I want to be able to charge these cells, so I'm going to use as little as possible. Okay. Stanley knife blade to trim the excess. I'm looking at these two. And there we go. And that is our 12 volts lithium ion battery pack. I know you'll be looking at that and thinking, well, that looks a mess. You're right, it does look a mess, but it'll do the job. So we'll connect it up to our circuit, and we'll just double check that we're getting the correct voltage out of our wire there. So we'll connect that wire there to the positive, and then I'll have to flip the board over and ground it to there. There we go, we've got bang on 12 volts. So we will just double check what voltage we are getting again. And yeah, we've lost half a volt going through the diode, so we're at 11.8, so that works perfect. Okay, now for the solar panel side of things. So we'll move these out of the way for the time being. So we know we've got our 12 volt battery pack and we've got our circuit there with our switch where we can select either solar or battery power. And now we need to take this apart. So, simple case of undoing the 4 screws on the front. That's 1, 3, and final one makes 4. Okay, now this was built in a hurry. And the wiring inside is rather shoddy because it was basically done as proof of concept. I just wanted to check that it was possible to run the LM386 from these solar panels that I'd selected. So, okay, that's the 1.5 volt solar panel connection, which at the moment is not being used. So we will leave that taped up. And these speakers are wired in series. So we will disconnect these. It just makes things easier for me if I can move the speakers out of the way. And yeah, so we've got an 8 ohm 1.5 watt and we've got a 16 ohm 3 watts. So that makes 24 ohms altogether. And it doesn't actually sound too bad. These are the actual speakers that were in this speaker to start with. This is actually out of the Bush dial-up internet TV. I took the TDA 2822M out of. And literally all I've done is hot glued the speaker that was in here into here, and likewise I've hot glued that speaker there into that hole there. Just so happened they were both exactly the same size, which is a bit of luck really. Anyway, we'll put that out of the way for now. Okay, so in here I will take out the LM386 board. It's literally just held in with the washer on the potentiometer, not the washer, the nut. Okay, so there we go. That circuit there is actually the exact same circuit that I made in the breadboard. No difference whatsoever. It sounds really good for an LM386. It's not the best sounding of chips at all, but doesn't sound too bad. Okay, so we now need to disconnect the power, and you can see what I mean, as in it was wired in a hurry just as proof of concept, because none of these are actually insulated. Disconnect that and then disconnect the negative wire. Be careful not to pull too hard, because I really do not want to ruin the solar panels. We've got 1, 2, 3 solar panels there. Those 2 are wired in parallel, and those 2 in parallel are then in series with this one. Sounds complicated, but it makes sense. It's the only way the voltage is added up correctly. And not only that, this big solar panel here gives off about, I can't remember if it was 200 or 300 milliamps. But when you wire solar panels in series, you can increase the voltage, but the current will only ever be, so the maximum current you can get will only ever be as large as the current from the most powerful solar panel. I mean, if I wired up this solar panel in series with all these, the whole circuit would be 1.5 volts, because that solar panel there only gives off 1.5 volts. The current would be higher, but now let's connect our connector to our solar panels. We'll just twist them together quick. I'll give them a quick run over with the soldering iron to join them together, like so. And then we will trim them down. So there we have the positive side connected up. And I'll now insulate that with a little bit of gaffer tape. If I'm careful about how I do this, I'll only need to use one piece of gaffer tape. So now we can connect up the negative wire. And then we can trim that down. And again, it needs insulating. So like I said, if I was careful, we could use the same piece of gaffer tape. And I believe we can. Okay, so there we go. That's our solar panel now connected to our handy little connector. We have our battery pack connected to our handy little connector. We have our circuit made. All we need to do now is put a hole in the speaker enclosure for this switch and screw the switch in. However, before we do that, I think it's rather prudent of us to just test the circuit, make sure it works exactly as we expect it to. So we will connect the battery pack up there and the solar panels there. Okay, and then this is our power wire. So got a black wire on there now, which is going to act as our I'm just going to solder it on, and then I just need to bridge it to both sides of the circuit there for both inputs. Okay, and then I'm just going to bridge it across to the same track that the black wire is in. And there's already plenty of solder there, so I should just be able to push that wire into the solder. Like so. That little solder bridge that I've just created there. And there we go, that should be perfect. So we've now got a positive and a negative to connect our amplifier up to. Okay, so just for the time being, I've just twisted the wires together just to test the circuit. I've reconnected the speakers. So now all we need to do is connect the battery pack to the correct place. Here we go. I'll just do the amplifier click and connect the solar panel to the correct place. Okay, so that's working on the battery pack. Right, so my hand is now over the solar panel. And as you can see, my hand is on the solar panel and the sound puts out. Let's flip this switch this way. And there we have it, we're running on battery power. And then if I flick back this way, we're on solar power again, and if I move my hand and push it into the sun, and there we go. Obviously there's not really enough sun to get it working, it's not in direct sunlight. However, proof of concept, it works. And that's perfect. That's perfect for what I need. I can now flick between solar and battery power whenever I like. Okay, so I've been and grabbed the drill, and we are going to drill a hole in the back here somewhere for the switch. So we'll start by drilling a pilot hole. And then we'll open the hole out to 8mm. Go. Now we'll just it just needs to be a tiny little bit wider. We're still going to end up with a little bit of a hole, but it'll be fine. Grab the hacksaw blade. I know this isn't really the correct tool for the job, but it's the only blade I've got that will fit through the hole. And then I can just use a screwdriver to, or rather a pair of pliers would probably be better, just to pull out the excess. And I think the switch will probably fit in there now. So what I need to do now is actually desolder the wires from the switch just so I can put the switch in and screw it in. Feed that through and we'll check it for fit. This needs to be a tiny little bit bigger, I think. Well, I think I can probably get that in there if I'm it needs to be a tiny bit bigger. Possibly not the neatest job that I've ever done, but provided the switch fits just like that, I'm really not going to care. So there we go. So that will be our selector for power from solar panel or power from the battery pack. We've got a hole there for the volume control, a hole there for the input. So now we just need to reconnect up those wires, get this board hot glued in place and connect it up, and then put the LM386 amplifier back into the speaker enclosure. be laughing. Okay, so that's going to be our power input for the amplifier. I think the easiest way for me to do this is probably going to be to desolder the wires from this Vero board, which is probably what I should have done in the first place. But I thought I was going to be saving a little bit of time. Obviously, if I'd have given it about 25-30 seconds more thought, I would have realised that I wasn't going to be. That's one wire disconnected. Two wires disconnected. And we'll get those reconnected back up to the switch. Now I was also going to put a main power switch on, but what I will do is I will make sure that whenever I've finished using this amplifier, that I flick it back over to solar power, and provided I do that, the battery will last. Okay. To do the same thing as before and hold the switch in there. Okay, now it's a case of poking all these wires back through from the back of the speaker enclosure. Like so. I need to find two small self-tapping screws to go in there to make sure that the switch stays in place. And then it's a simple case of reconnecting these wires through the Vero board. There we go. Okay, so we've now got our positive and negative connection there for our amplifier board. So now it's a simple case of connecting these up to the LM386 board. See if I can do this without burning myself. And obviously I can't. So that's one wire connected. Use some gaffer tape now to insulate the wires. And then we'll connect up these wires. See if we can't do these ones a bit more professionally. Like that. And then insulate those as well. Okay. So now we've got the board that we just made for connecting the solar panel and the battery pack. And the battery pack. So now I need to hot glue that board into place, find somewhere in there where we can put this battery pack, and then put the LM386 board back in. So we're going to put this in here somewhere where it's going to be easy enough for me to access the connectors for the battery pack. So I think I'm just going to put it there. The glue gun's now heated up, so I'll stick some hot glue on the bottom of the board and hold it in place for a few seconds. And there we go, there's the circuit board glued into place, switch connected up. Now it is a simple case of putting the LM386 board back into the enclosure, and it is literally held in with the potentiometer. So we'll put that in now. Battery pack out of the way a second. Make sure the board is lined up so that we can get the speaker connector in, which it is now. And then all we have to do now is simply solder the speaker back up to these wires here. So the white wire is our negative wire. All I'm going to do is twist those things together, give it a quick hit with a soldering iron, which will join the two together perfectly because they're both tinned already. And we will trim that and insulate it. And then simply connect the green wire to the positive terminal of this speaker. Now, I've done it like that because these speakers are wired in series. And then all we have to do now is connect our battery pack up. And slide it in there. Now I am actually going to use a bit of gaffer tape just to hold it to the bottom. I'm not going to use a lot of gaffer tape because I want this to be easy to get in and out. It's literally just enough to stop it from sliding about too much. So sort of that amount there will do, which will stop it from sliding left and right and forward and backwards. And then it's going to be a simple case of screw the front back on and the project will be complete. The only downside to this, like I said, is that because I haven't got any solar charging circuitry or a battery balance board, that when these batteries run out, I am going to have to take the whole thing back apart and take the batteries out and charge each cell individually. Now, I am going to buy a battery balancing board. I just haven't had time since getting out of hospital to get one yet. But it is on my list of things to buy to complete this project. And also, at some point, I'm going to put the extra 1.5 volt solar panel that's on top of this thing into use. And we're going to connect up an MP3 player. I've got one somewhere that runs on one AAA battery, so I know that that solar panel there will run it. Okay, let's give this a test now. That's running on solar power. Now we're on battery power. Solar power, battery power. There we go. If you've liked this video, don't forget to hit subscribe, hit like, hit the bell for notifications of my latest video, and I'll see you again next time.